Previously, you've seen that two methyl alcohol molecules, by virtue of their polarity, this delta plus, can be attracted to a delta minus of a neighbor. This will tend to hold these molecules to each other. I'm going to illustrate that friendship bond with this rather long peg that I striped. So this could represent an attraction, very weak attraction, between these two molecules, but it is enough to hold them together at room temperature in a liquid state. These, on the other hand, are methane. Methane is CH4, tetrahedral, non-polar, and there aren't any friendship bonds between these molecules. No polarity means no attraction. So when these molecules are tumbling, there's no attraction. They drift apart from each other. They are gases. That's a key difference in behavior, and it's based on polarity. Nonpolar molecules will tend to drift apart from each other. What's to hold them together? Random motion will drive them apart. Nothing to hold them together. Whereas polar molecules, random motion will tend to move them, but if their attraction is strong enough, they won't separate. And therefore, this will be a puddle of liquid. If we heat the liquid up, maybe the motion becomes strong enough that this bond does not hold, and then this molecule drifts into space, and this molecule, without any attraction to a neighbor, also drifts into space, and this, we've just evaporated the liquid. So when you look at things in real life, here's a liquid. Above it, this empty space is filled with gas. The liquid molecules must be attracted to each other. The liquid molecules often have friendship bonds that stick the molecules together, so they're able to move, they're liquid, but they have attractions to their neighbors. That's what this phase is. This phase above is not empty, it's filled with air, and air is made of molecules that are mostly nonpolar. Oxygen molecules, O2, nitrogen molecules, strong triple bond, but no attraction to their neighbors. So they don't stick together, they don't form a liquid, they're spread out in this gas state here. This is interactive physics. This is another way of understanding the behavior of polar molecules that can form friendship bonds. So here the green molecules are representing H2, hydrogen gas, nonpolar, and you see they have no attractions to their neighbors. The green molecules simply bounce off. And this is the behavior of gas molecules. They bounce off. There's large spaces between them. On the other hand, these red and blue molecules here have polarity, and you see when they find each other, they have some attractions. That would be representative of a liquid state. You can see they're still mobile, but they tend to stick together. So this big difference in behavior can be related to friendship bonds. So here, as these two approach, we can see in slow motion that the red atom has some kind of attraction. It looks like a magnetic attraction. It's actually electrostatic. So perhaps this red atom is delta minus, and this blue atom is delta plus. Because of that attraction, the two molecules are drawn together. You can see it. It just feels like two magnets being pulled together. And between these two, we could draw the dot, dot, dot of friendship. Here are four water molecules, H2O, 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 H2O. Right now they're separated, but their polarity will naturally draw them together. You can see friendship bonds have formed here. These are about to form friendship bonds, which are called hydrogen bonds. And as they do so, they are clustering together changing from the gas state to a liquid state. So this is why the title is forming a raindrop. This cluster of molecules is now in a different state. Liquid, perhaps even solid. As you see here, they get to the point where their motion becomes very restricted. That would only happen at a very low temperature. Gas molecules that are polar can readily be attracted, forming a liquid state or perhaps a solid state, a condensed state.